All right, thank you. If you get sick of hearing me, there's a feedback form on Slido. You can write it in the comments, like, less Philippe next year, and we'll take care of that. If you would like more of me, tell them as well, so they can actually give me a full day or something. I'm just kidding. Let's talk about authentication. Well, Thomas kind of overpromised that I would talk about authorization as well. That was a lie. I'm not going to talk about authorization. I'm going to talk about OpenID Connect. Who here knows what OpenID Connect is? All right. Who here understands how it works? Wow, brave souls. A few people. It's complex, right? It's complicated to understand what's going on. And I'm going to try to clarify the purpose of OpenID Connect. I'm going to talk about why you would use it, what the benefits are, and I'm also going to show you how to implement that in practice. And I'm going to show you some Angular code examples at the end. The Angular is in between brackets because honestly it's going to be about OpenID Connect. The examples will be Angular, but if you're doing React or Vue or any other type of web application, the concepts are going to be exactly the same. Of course, the code is not going to be literally the same, but everything else is applicable there as well. So hopefully this is going to be useful for each and every one of you. Let's dive right in. You probably recognize something like this. Every web application at some point starts with an authentication form. If you want to do end-user authentication, whether we like it or not, it's going to be a username and a password, or an email address and a password. There's some challenges with this mechanism, some challenges if you want to implement something like this. First of all, you're going to need a database with user accounts, with usernames and passwords, sure, not plain text passwords, as we saw yesterday, but properly hashed and stored passwords. But you'll have to manage that. That's definitely something that comes in. You'll have to handle permission management, like who can access the database, what are the permissions of the users, how can I translate that permission into an API call, and so on, and so on. And then the fun starts. Once you implement this, you'll find documents such as the OWASP ASVS with a bunch of requirements that say like, oh, have you thought about brute force attacks? What prevents someone from coming to the application and saying, hey, I'm Philippe, my password is chocolate? Wrong. Oh, my password is Belgian beer. No, wrong. My password is maybe Sachertochter, like the one there. Like, oh yeah, absolutely, bang, logged in. Brute force attacks happen a lot in practice. I mentioned this statistic yesterday in the panel. Especially for highly sensitive applications, these attempts are everywhere. Even more dangerous than brute force is a credential stuffing attack. Credential stuffing means that I break into another application or go onto black market, the dark web, and I buy usernames and password combinations. If I break into a crappy forum about, I don't know, wine brew in the municipality of Vienna, like we learned yesterday at dinner, you may have a username and a password on that forum. If I can steal that information, which may not be very secure, well secured, I can take that information and try to log into your bank with that. And if that succeeds, you're in trouble. Credential stuffing is a nasty attack because you typically don't see the brute force pattern. It's not like I'm hammering one account with any password I can think of. No, I'm trying one combination. If it works, I'm in. If it doesn't work, I move on to the next one. Really problematic attack to stop in applications. You'll have to deal with password managers. Hopefully, people will use password managers. There's a couple of patterns you have to think of when you want to use that. People will use your application on a mobile phone, on a mobile browser. Logging in works a bit differently there. So these are things you might want to take into account. Multi-factor authentication with USB keys or web authentication. All of that is, again, implementation effort on your end. And of course, the users will maybe want to log in with social login, with Google or with Facebook or something, and you'll have to implement the support for those mechanisms as well. That's what traditional login means today. Based on this picture, when I talk to clients, I often tell them, why would you want to do that yourself? What on earth makes you think that this is a fun project to build? Like, let's build an authentication service. Like, absolutely freaking not. If you can avoid it, please do. Don't make your application publicly accessible to everyone. That's also not a good practice. But you can offload all of this to an identity provider. And that's what OpenID Connect allows you to do. It allows you to offload user authentication and all of this crap, basically, all of these challenges, in a better word, to an identity provider. You can use, well, you could use Google for that, one of the social networks, they often provide that because they get some benefits from that. Or you can deploy your own product that handles all of this out of the box. Whether it's a product that you buy or an open source product that you use or an open source library that you integrate, doesn't matter. As long as it handles all of this, that would be beautiful, right? That's what OpenID Connect allows you to do. Here's what that looks like in practice. I'm going to explain the purpose of OpenID Connect with a very practical example, which is Netlify. I am in no way associated with Netlify except that I'm a customer of their free product, which is absolutely awesome, by the way. So my website is deployed on Netlify, straight from GitHub, worked like a charm. They offer login features. They offer social login, so I'm going to show you how that works with OpenID Connect behind the scenes in an example. So there's me, right there, and there's Netlify. Logging in, I'm going to show you how to log in with GitHub. So GitHub is going to be in the mix, and of course we have a browser. This slide is outdated by now because I use Brave, not Chrome, but you kind of get the idea. Probably nobody would recognize the Brave logo anyway, so Chrome makes more sense here. Netlify is what we call the client or the relying party. Netlify is the one that wants to authenticate the user. So it's going to start that process from Netlify itself. So it's going to ask my browser to go to GitHub. So Netlify is going to tell my browser with a redirect typically from, hey, go to GitHub with this page. I'm going to show you the URL to do that later when we dive into the details. And my browser is going to obey that order and follow that redirect all the way to GitHub. And at GitHub is going to be like, who the hell are you? And I'm Philippe. And GitHub is like, oh, okay. So concretely, this means I'm going to end up at GitHub, and GitHub is going to say, hey, I don't know who you are. Sign into GitHub so that you can actually continue with Netlify. So GitHub knows that Netlify is asking GitHub for an authentication of a user, but needs me to authenticate first, obviously. Otherwise, if GitHub doesn't know who I am, I cannot authenticate. So I'm going to log in with my username and password, and off we go. Of course, multi-factor authentication is enabled on my GitHub account, very important. So GitHub is going to ask me to plug in my YubiKey and hit that button. Very important. GitHub, in this case, is the identity provider, handles all of that for Netlify. Netlify doesn't care about any of that at this point. When that happens, GitHub is happy. GitHub knows that it's really me. I've proven extensively that I know the secret password as well as have that YubiKey in my possession. All right. GitHub is happy, and it's going to send my browser back to Netlify. It's going to answer to this request like, hey, can you, or redirect the browser again, sorry, not an answer, redirect again, back to Netlify with some information about who I am. And the browser is going to follow that and load the page from Netlify again. And when that page is loaded, in the URL is going to be a piece of information that can be used to figure out that I'm actually Philippe. So Netlify will now show you a page like this, Philippe Direct's team, which is empty because I haven't done anything. This is not my main Netlify account. I have another account for other stuff. But Netlify now knows who I am, even has my picture from GitHub, but hasn't seen my username, password, my information, anything. All of that came from GitHub by relying on that OpenID Connect mechanism. That's what OpenID Connect has to offer. So if you take this image again, all the green stuff is OpenID Connect. The gray stuff on top is custom. The gray stuff on top is not part of the OpenID specification. The spec says like, however, the identity provider wants to authenticate their users, that's not our concern. As long as they do some authentication, that's up to them. But OpenID Connect specifies how to interact between these different parties, how to send the information back and forth, how to protect that information, and so on. And that is what OpenID Connect has to offer. This is also known as social login, because how you look at it, well, it kind of matters a bit how you look at it, but GitHub in this case is a social network. It's a code repo service, sure, but in this case, you would group that under social login. It would work the same way with Google and the other services. Facebook kind of does something similar, but it's not OpenID Connect. So they have their own custom thing, but it looks very similar to what's happening here. I see some of you thinking like, I don't want social login. Nobody wants to log into their healthcare information system with their Google account. Well, some people would actually, but you probably don't want to support that. But the same protocol works in an enterprise setting. So let me use another example to explain how that would work in an enterprise setting. This is Restaurate, a restaurant review application that I use in my training courses. This is an enterprise application. Well, not really, but sure, you get the idea. It's an implementation I built. It's not very great, but it works. It does what it needs to do. And I want to log in there without having to implement custom authentication. So what I'm going to do is I'm going to use OpenID Connect and an identity provider. The only difference is, instead of asking GitHub to run that thing, I'm going to run that myself. I'm going to buy a product, or in this case, use another free product for that, which actually works really well, which is Auth0. Auth0 is a cloud-based identity provider. You create an account, and you get your own little identity provider on their services. They run everything for you, and they're absolutely awesome. As a full disclaimer, I'm an Auth0 user, again, but they recently invited me to join their ambassador program, so they also give me free swag. They don't pay me, they just give me free stuff, which is also pretty nice. Just so you can't claim that I'm selling you something, well, I'm really, really not. It's just a great product, easy to get started, to try out a few things. Of course, there's vendors that offer their own solution. You can deploy on-premise, like whatever you want. You have cheap options, you have expensive options, and you have open source options as well. I'll show you one later when we dive into code examples. But regardless of what product you're using, you're going to end up here again, a login form. In this case, it's not GitHub, it's essentially a customly owned identity provider run by Restaurate, in this case, the restaurant review application. So here you can create a user account, or you can log in with an existing user account, and again, that service is going to handle all of the stuff that you want it to handle. User storage, multi-factor authentication, brute force protection, all of that is Auth0. Not my worry, Auth0 will handle this for you. So the user logs in and ends up at the application in an authenticated fashion. And that is how you do that in your own environment. That's how enterprises do that. If you have a couple of applications in your company, and you have a single sign-on system, today that single sign-on system is OpenID Connect. It might still be something older. If your applications have been around for a while, it might be SAML or something, but if you build something today, that will be OpenID Connect. You can hook that into your Azure, Active Directory, whatever you're using. It all connects together one way or another. So in this scenario, we have the same setup, exactly the same scenario as before. You can put them next to each other. The only difference is that this is now a Restaurate application instead of a Netlify application, and this is the Restaurate identity provider instead of the GitHub identity provider. But in the end, it is the same. What you get here is you control your user base. While you don't run the product yourself, you still configure it, and you control whatever happens there. You are in full control, while with GitHub, you really are not. This is much more powerful, this scenario, but requires you to run more, so it depends on the use case what you want to use. That brings me to the first takeaway. And the first takeaway is that OpenID Connect is about delegating authentication. That's what the protocol offers. Delegation of authentication to a third-party service. Whether you run that third-party service or somebody else does is, well, let's leave that in the middle. This allows things like single sign-on as well. If you have 10 applications that use the same identity provider, you will have a single sign-on mechanism that you can leverage as well. User has to log in once, and then every other application can easily reuse that existing login in their application as well. Of course, assumes a trust relationship and so on, but you get the idea. By the way, this is an insanely complicated topic, so if you have any questions, please use the Slido application, and you can talk to me afterwards as well, because trust me, this is something where you'll have a lot of questions. They'll come up, and they'll keep coming, and it will never end if you start going down this rabbit hole. That's why I work with a lot of customers that actually struggle with figuring out what they need to do exactly here as well. All right, so how would you use it in practice? How does this hook into your application lifecycle or whatever you're doing? Well, let's talk about one simple case, using this for authentication only. This is how I run my custom training application where you can solve some labs during my workshops. It's basically a front end and a back end working together with a traditional server-side session object because it's easy and I'm a lazy developer. And I only have like 30 users at the same time when I'm teaching a class, so it kind of can handle the load on a single server, so I'm good there. So how does it use? It uses OpenID Connect with Auth0 as well. So how does it work? Well, you have this session between the client and the backend, and then you have the browser of the user and the identity provider. And the backend here is going to ask the user to log in, like, who are you? And it's going to start that flow again. It's going to take the browser back to the identity provider, and so on. So the browser is going to do the whole dance with the identity provider for authentication and signing up and so on. And in the end, well, that's where authentication happens. And in the end, it's going to return that piece of information to the backend application. And that backend application can now authenticate the user. In practice, this is going to be an authorization code or an identity token. That's a detail of the flow. I'm going to show you a very concrete example in a couple of slides. This backend can talk to the identity provider depending on what specific flow you're using. There might be a need for back-channel communication back and forth as well, but the browser is no longer involved there. All right. This is to exchange that code for an identity token if you use that particular flow. A detail that doesn't matter much, but this is how the interaction happens in that scenario. All right. It's one case. The second case is when you have a front-end only. Looks a bit of the same, except there's no back-end anymore. So if you build something like this, your full stack is a front-end only, so you can call yourself a full-stack Angular developer, which is awesome. Anyway, the same protocol can be used in a front-end scenario, but in this case, the front-end is going to be the one initializing the authentication. So the front-end is going to navigate the browser basically to the OpenID provider. There's going to be the authentication happening there between the browser and the ID provider, and in the end, you're going to get that piece of information back in your front-end. And that piece of information in your front-end can be exchanged for the necessary information with the identity provider by calling that API with XHR, very straightforward essentially, and you get your identity token. And now the user is authenticated to the front-end Angular application, which doesn't mean a thing. You cannot authenticate to a front-end. I mean, there's nothing to authenticate to, right? It's a static code base. So what does this mean, really? Well, this means that the front-end gets information about the fact that you're authenticated, and it can show you, welcome, Philippe, with your picture. And you as a user will enjoy that user experience. It's like, oh, awesome, beautiful. But of course, the real features come from the front end doing something, and that means calling an API. And that API call, that is something that's not part of OpenID Connect. But calling that API requires some kind of token to show who you are and what you're trying to do and whether that's allowed or not, and that is what we call OAuth. And OAuth and OpenID Connect are very closely linked together. OAuth was there first. OAuth was there first to call APIs from clients with tokens. Well, this is a very, very oversimplification of OAuth, but that's essentially what it allows you to enable. OpenID Connect was built on top of OAuth. It uses the same flow, but instead of this access token to call an API, you get an identity token with information about the user. And that's why these belong together, because they're the same flow, and depending on one parameter, you either get one token or the other token or both tokens. In this case, our front end would request both tokens, know who the user is, customize the UI, be certain that the user is logged in and is Philippe, and then call the API to create a review in my name. It will call the API slash reviews. The token will hold my identity information in one way or another, and the API will know, oh, it's Philippe, and create a review in my name for that application. And that's how these things hook together. Of course, on the left scenario, the backend, yes, you have a client who can use the backend, but if the backend decides to call other APIs, you can use OAuth there as well. That's the whole beautiful thing about this whole protocol set or suite or framework, that you can build whatever you need. So here, the backend could ask for both authentication information and an access token, and then call an API on behalf of the user. For example, you may have seen that the slides for this talk are on my Twitter feed. So I got some followers from the conference, so everybody else should join as well. On Twitter, very important. But that tweet was scheduled by a backend service, and that backend service used OAuth to call the Twitter APIs to send out that tweet 10 minutes before I started talking. Which is awesome, because I don't have to stress about, I still have to write the tweet and typos and mistyped URLs and stuff like that. I can do that upfront on my laptop. And this is what OpenID Connect has to offer and how it combines with OAuth. Using OAuth effectively is a whole different story. I'm not going to talk about that here. If you want to know more, you can talk about me later. or you can follow me on Twitter and wait a couple of months because I'm actually building online material to teach people about OAuth. Different story. We need a lot more time to talk about OAuth if you want to. So I promised you dirty details, right? I see you aching like, come on, how do you do that? I don't want to see arrows. Well, I'm going to show you more arrows, but I want to see URLs. As dirty as they can get. Well, hold on 5 seconds and you're going to be super, super happy. So, the scenario from before, how does it happen? Well, sign in with GitHub. Netlify starts the flow, the browser follows the redirect, and that looks something like this. You want the dirty details? Here you go. Of course, in reality, it's just one very, very long URL. There's no nice layout with colors. You have to just figure out what the hell that thing says. And some of these will be URL encoded, so they'll be even less pretty than what you see here. But what's going on here, I'm actually going to have to stand here if I want to highlight things. What's going on here is that this is the OIDC endpoint at GitHub. So that's where you send the browser to. That's the endpoint that will decide what's going on and to show the login page and so on. This here, the response type indicates the flow we're running. I told you that you can decide what kind of token you want and how you want to receive it. That's where you specify that. In this case, we're telling GitHub, when you return to us, I expect an identity token with information about the user, as well as an authorization code, which I can exchange for an access token, so I can also call APIs. That's what we're telling GitHub here, and that's called the hybrid flow in OIDC. And then here, this says what exactly we want to get, what the permissions we are requesting. We're requesting permissions to get identity information, an email address, and profile information, which typically includes a picture. And that's what we are asking as Netlify. That's how we send that request to GitHub. All right. When GitHub receives that, it's going to do its thing. It's going to show you the login dialog and request client authorization. So this part, again, is not spec'd by OIDC. This part is, there's some suggestions in the spec, like you might want to do this or you can do that, but ultimately it's up to you. In this case, GitHub is not going to give out my personal information to just anyone who asks nicely. No, GitHub is going to ask me, dear Philippe, are you sure you want to give your personal info to Netlify Auth? Because at this point I can say like, no, thank you. But in this case, it's actually pretty cool, so yeah, I'm actually kind of okay with that. By the way, the permissions that Netlify asked before, GitHub can decide to show me what exactly they're asking and allow me to say, no, thank you. If they're asking for my super personal information and I don't want to allow that, I can typically say, I don't want this to go through, and I can cancel the whole flow. All right, so then we go back to Netlify with a set of redirects again, and that looks like this. So it's again a redirect. You can see here it's going back to netlify.com. By the way, the example is based on real life, but not exactly the same as real life, just so that you know. But it's going to go back to netlify.com. And in the URL, you'll find a couple of parameters, like the code. And the code is what Netlify can take to exchange for tokens. The code is basically meaningless except for this one-time exchange. That's an OAuth thing. In this case, you have the identity token as well. The ID token, that's a JSON web token containing identity information about, well, actually authentication information about the user. And that's what Netlify will use to figure out who the hell I am. I'm going to show you what that looks like in this slide. That's the JSON web token. Well, that's an example of a JSON web token, which contains information about my authentication. We requested email information, so there's an email here. GitHub says that my email is verified. Awesome. It's issued by github.com for the Netlify client. The most important piece of information in this JSON web token is the last line, the SUB claim. The spec authors for JOTS have a fetish for three-letter abbreviations. SUB stands for subject. The subject is a unique identifier within the domain of the identity provider. Concretely, within GitHub, this is my unique identifier. I honestly don't remember if this is actually my identifier or not. I've built the slides a while ago, but I'm kind of sure it is. So if you ever see this identifier, that's me on GitHub. This will never, ever change. I can change my name, I can change everything else, but this identifier will never, ever change. So what Netlify does now is it takes that identifier, goes into the database, and queries select star from users where user ID is this one, or SUB is this one. And then they know, like, oh, that's this account. They can retrieve my settings. Well, I don't know if they use SQL, but you get the idea. They can retrieve my settings, and they can consider me logged in and do whatever they think I need to do. That's how OpenID Connect works. How does OAuth fit into the mix? I should stay here, I guess. How does OAuth fit into the mix? Well, Netlify by itself doesn't do much. Well, I'm kind of guessing you can do stuff with Netlify only, but what I do with Netlify is I deploy stuff from GitHub repos, which is actually pretty cool. I just commit a file to the master branch of a GitHub repo containing the website files, and Netlify fetches it, builds it, and deploys it. Beautiful. I really enjoy that setup. So here they exchange that code for tokens, an access token. Then they call GitHub to access that repo. They get the latest data, and they deploy that website. And this process is independently of this process, meaning that this can go on and on and on without me being present. So if I push something into the repo in an hour, Netlify will get a notification from GitHub, will access that repo, get the files, and do the same thing again, and again, and again. And the next time I want to log into my Netlify account, I go to netlify.com, and Netlify says, who are you? And I'm going to run this part of the flow again. And that's how these things hook together. All right. It's the same story for the front-end application. So if you make this an Angular application for retrograde.com, it's the same exact flow. There's one detail that's different. Here, skip back. Here, Netlify is a server-side application. Server-side applications run in something we call a secure environment, where secure is debatable what the exact meaning is, but in this context, it means an environment that can handle client credentials, a username and a password, or a private key for this particular client, so that GitHub knows who the client is when they exchange the code. That's a security measure. On the front end, you heard Mark's talk about mobile security. You cannot hide secrets in mobile applications. Same goes for web apps. Yes, you can write dirty JavaScript, but somebody will be smart enough to find that secret somewhere. So don't put it there. It doesn't work. So Angular applications do everything else the same, but they can't use a secret here, so they can't authenticate in step 7. Which means if somebody can steal this authorization code here somewhere, they will be able to get tokens in your name, which results in all kinds of nasty problems. And that's why they added something new in this for flows like this in web and mobile applications. And that new thing is called PKCE, Proof Key for Code Exchange. The reason OAuth and OIDC are so complicated is because of crazy terminology. Proof key for code exchange, I kid you not. I have no idea what it means or what it's supposed to mean. I know how it works, but I don't know where the name comes from. Anyway, PKCE is basically a one-time password for a client. Here's how it works. Instead of authenticating with a fixed, pre-shared, or public key-based secret, the client is going to generate its own secret. The client just generates a random string in step 1. That random string, it keeps secret for a while. And it calculates the hash of that random string. And that hash is called a code challenge. It's a SHA-256. And that hash is sent to the server in step number 2, 3, and ends up there in 4. And then everything happens just like before. We get our authorization code and identity token. The app says, hi, Philippe, and exchanges that code for a token to call the actual APIs. In step 9, the backend app would have authenticated, like, hey, I am truly the Netlify client because you gave me the secret before, and here is me proving that I know it now. But here we can't do that. So instead, we give the server here in step 9 that secret we generated ourselves and kept secret for a while, that random string. Because that random string, nobody else knows that string. But the server already has the hash of that string. So now it can take that string and the hash, calculate the hash again, and compare. And if the hash is the same, then we have proven that we as a client knew that secret when we started step 2, because we had the hash for that. And if it's not the same, then something weird is happening and just abort. Like bailout, nothing will ever happen again. with this interaction. And that is why this is kind of a one-time password. This acts as a one-time password to ensure it's the same client instance starting the flow and completing the flow. And this is crucial for mobile applications and recommended as a best practice for web applications. It is absolutely mandatory on mobile. You cannot run OAuth and OpenID Connect on mobile without this PXE mechanism. That's considered to be a vulnerability. On web, the old way of doing things is kind of okay, but the new way is better. So if you're building a new app, this is what you run in Angular. All right. Code. Because everybody's like, yeah, fine, PowerPoint slides. Show me code. Code. How do I do this? Well, it depends. It depends on what library you want to use. 5 years ago, this was a lot of implementation work for you. Today, it's finding the library you like, the one you want to use, and calling that library. And the library will handle all of the dirty details for you. Here's one example. npm install Angular, where is it? Angular OAuth 2 OIDC. You configure the library. It's like a bit of JSON configuration, like which identity provider you want to use. Like, oh yeah, this Auth0 instance, awesome. Done. Configuration, you call it. Basically, there's going to be a login button in the Angular app, and it's going to be on click for that login button is this function, init code flow. Done. It's going to generate the right URL and send the URL and get the tokens back and process the tokens and get the information out and basically get you that information in a callback, and you're done. You know what the best part about this is? It's a local product. It's built by an Austrian guy, Manfred Steyer, and he actually he builds and maintains this library, so if you like Austrian software, use it. It also means you can sue him in Austrian courts. No, it's open source, so it probably doesn't count here, but there's other examples as well. So today you'll find that most of the vendors offer toolkits for languages, like Auth0 has libraries for every language you can imagine, or almost every language. So here's the example for Auth0. Include their SDK for single-page applications and call the library, and it will handle the details for you. Of course, the other one is OIDC certified, works with all identity providers. This one is probably very Auth0 specific. I haven't checked whether this works with other providers, but there's a chance this might not be the case. This is vendor specific. But still following the standard, so there might be some interoperability. And then an open source alternative, there's a Java product called Keycloak, which is basically an open source authorization server handling all of that out of the box. And also Keycloak has a JavaScript adapter that allows you to call this flow in a very easy way. And that's essentially the simple way of implementing that. That's why it's for Angular between brackets, because this applies to a lot of different types of applications as well. And that brings us right here. Use the right OIDC flow for your application. There's a bunch of different flows. The ones I've shown you here are best practices. A backend application uses client credentials for the code exchange, and a front-end or mobile application uses PXE. That's a massive simplification of the landscape. It used to be like maybe this or that or this or that. Now it's this or this. Very easy, very straightforward. There's a few other flows, but I'm not going to talk about them right here. All right. So this is what OIDC brings to the table. For authentication, this is all fine. But if you start using this in a more advanced setup, like an enterprise setup, you'll run into issues, questions, challenges. Like, oh, that's cool, but what if I want to log out? What does a logout mean? Do you want to log out of one application or out of your account with the identity provider? Because if you log out of one application, and you still have a session with the ID provider, then the application can just log you back in because there's no interaction needed for that. So what does a logout mean at that point? And again, I can't answer that for you, but there are specifications that handle things like session management with OpenID Connect, how you can check if a session is still alive, yes or no, as an application, allowing you to decide how to handle that. There's logout mechanisms where you can actually cause a centralized logout being pushed to all clients. So what you can do is you can go to your identity provider and say, I want to log out. And if you log out from your central identity provider, and that single sign-on session is no longer alive, you might assume that you should also be logged out of all clients using that session. And this specification allows you to do that in the front channel. It's a front channel logout going through the browser, sending requests to all the applications, hey, this user should be logged out. And you can do the same in the back channel, where servers talk to servers, more useful in an enterprise context where you actually have that control to make it happen. But all of this is part of OIDC. It goes much beyond authentication alone. That brings me to the final concept I want to tell you, a few of the advanced cases, and this case is about federation. So remember Netlify using GitHub? You know what GitHub can do? GitHub is an identity provider, and GitHub can say, you know what? We allow you to log into GitHub with Google. And Google can say, we allow you to log in with Google with some other provider. Well, they're not going to do that, but they could, in theory. And that's what we call federation. So essentially what you can do is, where is my animation going? Awesome. I guess I'll be improvising the last couple of slides. Fun. All right, so what you can do with this federation concept is basically an OIDC provider, like GitHub in this example, can basically start a new flow with another provider. And they can ask you, let me use Auth0 as an example, that's better. So the rest-of-grade application logs in with Auth0, or delegates authentication to Auth0. And with Auth0, you saw this on the form before, you had a button, sign in with Google, allowing them to delegate again to Google. You can do your thing with Google. They send an authentication token back to Auth0, an identity token, sorry, and they take that information and give that to rest-of-grade.com, telling like, hey, this user logged in with Google, and here's their ID, and so on and so on. And that gives you the opportunity to, it still responds to some things, but that gives you the opportunity to actually hook different things together, and integrating social login is one of these examples. A business case, or more enterprise example, would be integrating Active Directory. If you could, for example, use that identity provider and then delegate authentication to Active Directory for employees, that would also be a very useful scenario. And let me quickly see if I can get, okay, so in good news, it's not my computer, but PowerPoint. So I can live with that. So let me kill that thing and try again. Awesome. So it's no longer live coding that can go wrong, it's anything with computers, basically. So for next year, I expect we have very beautiful blackboards here, so just a whole box of chalk, and we can start drawing OAuth and OIDC scenarios next year. Bad news for you is I suck at drawings. There's a reason I use pretty icons. Anyway, this is a federation scenario I was talking about. Sorry for that small interruption. Basically, GitHub could delegate, again, to other providers, and even internal services like your Active Directory service from your Windows domain. That's called federation or brokering or whatever you want to call it. And the reason I actually wanted that slide back is for this, because there's no way I could explain this without confusing you. What you can also do is build scenarios like this in your internal systems. This federation is just a general concept, and what you build with that is completely up to you. So what you could do, for example, is you could have two identity providers, one for users and one for employees. Not all your users are employees, and not all your employees are users, but there might be some crossover. And what you can do then is have a login on your user's identity provider, and that one can federate back to your employee provider. And that allows you to have clients that are for employees only, that use the employee login, and clients that use the user's login, which can federate or broker to the employee identity server. And that essentially allows you to construct complicated scenarios where you don't have to duplicate user accounts. No, you can leverage features like this. Also means if you want to if you want to terminate one of your employees the right way, if you want to terminate, as in fire, one of your employees, they automatically become invalid here. Also means that they can no longer log in there. And that brings me to the takeaway, which is that OIDC is a lot more than authentication alone. OIDC goes a lot further. There's a lot of very advanced use cases, and the protocol suite is still in active development. So if you're interested in that, definitely get involved. And a final note, I built some security cheat sheets for developers as well, so you might be interested in that. The link is right here. You can also find them on Twitter. If you look up my name, I'm not that hard to find. And with that, I want to thank you for sticking up with me for yet another session. And this is probably the last one for this conference. You never know.
You never know.
If you have any questions, I'll be happy to answer them now or after the talk. Thank you.
We did save a couple of minutes for questions, so we're going to ask some of the audience.
What is your experience with Keycloak?
I'm really fighting myself to not say it depends. What's my experience? It's good and, well, yeah, virtual. Let me start again. Pretty good, actually. Keycloak is a solid product. Keycloak is free and open source, but it's from Red Hat, and they have a sort of commercial version, part of Red Hat, called Single Sign-On, which is better supported, has the whole support contract and all of that. So it's a really solid product. It's really configurable. The downside, I would say, it's kind of a, not really monolithic, but it's a single entity. Like it's a server doing everything, and that might not fit every use case. But if you want to get started, it's basically download Keycloak, start it up, and you have a full identity server, full OAuth authorization server ready to go. So yeah, it's a good product, and their JavaScript libraries are really good as well.
Another very popular question was, can you please describe the difference between the term authentication, OAuth, and identification, OpenID? Why can't OpenID provide authentication by itself?
Wow. Okay. There's a few things mixed up there. Let's talk about terminology first. Identification is not very useful. Identification is me saying, I am Thomas organizing sec4dev. That's me identifying as Thomas. Means nothing. Everybody can identify as anyone. That's basically what email is. You can send an email in anybody's name. Authentication is backing up an identity claim with concrete information. So if you would challenge me like, no, you're not Thomas, show me your passport, I probably don't have his passport with my picture. Well, some shady people might have that, but I don't have that, so I would not be able to authenticate as Thomas. So if I show you my passport as Philippe, you would be able to confirm that I'm indeed Philippe by trusting the Belgian government to issue proper passports. That's identification and authentication. OpenID Connect provides authentication. It does that by delegating to a provider who does something, but the item you get back, the token you get back, that's basically information about an authentication. This means that for this analogy, the identity provider would be the Belgian government in this case, which you decide to trust on whatever identity information it provides you. And instead of a passport, it's an identity token, but it's signed by that identity provider. And if you trust that identity provider, you trust that information in that token. And that's what's going on. OAuth is the same flow, but provides an access token. And that access token does not mean anything to a client, to an application. It means something to the API you're calling with that token. And it contains similar information. It contains who it was issued for the Netlify client, which the user is, Philippe de Ryck on GitHub, with this very long GitHub identifier. And that allows the API getting that token to decide who's calling me. Like, oh, the Netlify client, cool. And who's the user? Philippe de Ryck. And you want to access sec4dev's private repos? Like, no. That doesn't fly. You're not allowed to do that. And that's the authorization part. OAuth is about how to get that token, not how to use that token. Using the token is out of scope for OAuth, but getting the token, that's what OAuth supports. And that's how these things hook together. I hope that answers this question. If not, we should talk about this after the session.
Thank you. And the last question, but what if my GitHub EG gets hacked? This also grants the hacker access to all services where authentication via GitHub is possible.
Yes. People complain about me not giving short answers.
Perfect answer.
No, yes, that would mean exactly if that central service gets compromised, then of course, if I know your username and password there, I can easily go log into all of the services where you have that account, absolutely. That's why I had multi-factor authentication enabled on GitHub as well.
Thank you very much.
Thank you, Philippe.
You're welcome.